Okay, if you will label your notes, please. 4-4, combining functions. The essential question is, how is combining functions similar or different from combining like terms? Give you a second to make sure those are titled. Okay, first we're going to start out, before we start combining functions, we're going to start out with evaluating functions. Example 1. We're going to be given a function. It doesn't always have to be f. It can be some other letter like m of x equals, say, 7x minus 4. And it asks us to find when what m of 2 equals. So essentially, we're asked to find the value of this equation when x equals 2. This is not m times 2, this is m evaluated at 2. So all we do is take the 2 and plug it in. So instead of the x, we now write 2 equals 7 times, instead of the x, we now write 2 minus 4. Then we have to follow PEMDAS. Please excuse my dear Aunt Sally to simplify. So inside the parentheses, there's nothing to do. There's no exponents, so the next thing on the list is multiplication. 7 times 2 is 14. 14 minus 4 is 10. And bring down m of 2. It's not m times 2, it's m of 2. Evaluated at 2 equals 10. Okay, let's try another evaluating problem. Example 2. How about g of n equals -3 times the absolute value of 2 times n minus 5. And we're asked to find when the value of g of n when n equals -4. So whatever number here is in the parentheses is representing, in this case, n. Sometimes that's our x value, in this case it's n. We're going to take this -4 and we're going to evaluate or substitute in, wherever there's an n, the number -4. So underneath, write g of -4, so that's not g times -4, it's g of -4, equals -3, absolute value 2. Whenever we're evaluating, we should put parentheses, especially when that number is negative. It's important to have parentheses. 2 times -4 minus 5, close the absolute value. Again, we need to follow PEMDAS. Please excuse my dear Aunt Sally. Now, P stands for parentheses generally, but it actually stands for anything that's grouping. So square roots can group things, and also absolute values can group things. So we're going to do inside the grouping symbol first. And inside the grouping symbol, we have multiplication and subtraction. So according to PEMDAS, which one comes first? Multiplication or subtraction? It would be multiplication. So I'm just going to carry down my -3 and my equal sign and do my multiplication. 2 times -4 is -8 minus 5. Close the absolute value. Make sure your absolute values are nice and long and tall so they don't look like ones. Now we need to finish inside the grouping by doing the subtraction. -8 minus 5 is -13, absolute value. Now remember, the definition of absolute value, we talked about this when we were finding the absolute value of complex numbers and graphing them on a complex plane. The definition of the absolute value is distance from 0. And it doesn't make sense for distance to be a negative value. So absolute value of every number besides 0 is always positive because distance is measured in positive. So we can change this absolute value negative 13 to timesing by positive 13. And negative 3 times by positive 13 is negative 39. And let's bring down our left-hand side. So we're going to be working vertically. Don't go out horizontally, work vertically. And keep your equal sign each time. Just work on the one side that has the simplification that we need to do to evaluate. And we get g of negative 4 equals negative 39. Okay, so that skill is going to help us as we combine functions. Okay, we're going to start with a simple combination of functions. Okay, example 3. Now, when we're combining functions, we're actually told, first of all, what the given functions are. So, given h of a equals 4a plus 2 and g of a equals 3a minus 5. Okay, we're going to first find h of 1 plus, what do I have, a g of 1. So essentially it's the h function plus the g function evaluated when a equals 1. So I'm going to make it simpler first. I'm just going to look at h of a plus g of a. H of a is 4a plus 2. So 4a plus 2 plus g of a. G of a is 3a minus 5. So all you do to add them is take their parts in the order that was given. Technically we can add in any order, but we can't do that for subtraction, so just keep them in the order as given. First we take the h function and add it to the g function. Now we're going to evaluate when a is 1. So now I'm going to take all of the a's and replace them with parentheses with a value of 1. So each of these a's I'm going to put parenthesis with a 1 inside. So 4 times a becomes 4 times 1 plus 2. Plus 3 times a becomes 3 times 1 minus 5. And again, we follow PEMDAS. Please excuse my dear Aunt Sally. The first operation we have in order, we have multiplication, addition, and subtraction. The first one we need to do is multiplication. Timesing by 1 is not hard. So 4 times 1 is 4. 3 times 1 is 3. So I did all of my multiplication. I see addition and subtraction. Addition and subtraction should be done left to right. So I'm going to do these two first. 4 plus 2 is 6. Carry down the rest. Now left to right, 6 plus 3 is 9. And lastly, 9 minus 5 is, oops, I was going to write 9 minus 5 is 4. And then carry down our problem. So it's nice and neat. H of 1 plus g of 1. So h plus g evaluated, I kind of did a really bad box there, evaluated at 1 equals 4. That's combining two functions and evaluating them at a given value. So this one, we practice addition. Let's try it again with subtraction. We can even use the same functions. So let me make sure I'm on the screen here. Example 3, again given. You don't have to rewrite this, but unless you're on a separate piece of paper, but since I moved to a different paper, I'm going to rewrite them. H of a equals 4a plus 2. H of a equals 4a plus 2. And g of a equaled 3a minus 5. Okay, this time we're going to do subtraction. So given those, we're going to find what h of 3 minus g of 3 equals. So again, I would start with ignoring the inside inside constant that we're going to be evaluating at, and just look at h of a minus g of a. Let's start there. So h of a is 4a plus 2 minus, what was h of a? Minus g of a. However, we're not, if you just put minus 3a minus 5, you'll only be subtracting 3a. That's not the whole function. We need to subtract everything in g of a. So make sure you put parentheses. Now we've done this many, many times. What happens when we subtract a binomial? It's not just subtract 3a, it's subtract 3a and subtract a negative 5. So we need to make sure we distribute that sign to both. Subtract a negative 5 becomes plus 5. Okay, so when on subtraction, you'll want to make sure you change all signs. Because when you subtract a negative, it changes to positive. When you subtract a positive, it changes to a negative. Or you can think of this as a negative 1 being multiplied to both, which also changes the signs. Okay, after you change the signs, all we need to do is combine like terms. We could have done that in addition, but we ended up actually, or you can plug in here. I guess you have a choice. Plug in to evaluate. Evaluate. Okay, I'm going to combine like terms this time. See how I have 4a minus 3a? That's 1a. I have positive 2 plus 5. Those are like terms because they don't have a's. Positive 2 plus 5 is plus 7. So h of a minus g of a is a plus 7, but you're not done because the original problem had us evaluating at 3. So let's plug in the 3. h of 3 minus g of 3 equals 3 plus 7. So we get 10. And I'm going to rewrite this side. h of 3 minus g of 3 equals 10. Okay, so you do have an option here. After you've plugged everything in and changed signs if needed, you can start by combining like terms, or you can just start evaluating. If I had chosen, I'll put here alternate. If I had chosen to just evaluate, I was at 4a plus 2 minus 3a plus 5. This part and this part. All I would have done was changed all my a's to the 3 that we were requested to evaluate at, because it said h of 3 minus g of 3. And then I just very carefully follow, please excuse my dear Aunt Sally. 4 times 3 is 12. Negative 3, notice it's a negative 3, times 3 is negative 9 plus 5. And we need to do addition and subtraction left to right. So 12 plus 2 is 14, then carry down the rest. Left to right, so in this case we need to do subtraction before we add. 14 minus 9 is 5, plus 5 is 10. See, we get the same answer for h of 3 minus g of 3. We get the same answer. I would probably say that this method up here of combining like terms first ended up being shorter. So it's just your preference, whichever one you like better. Okay, so this was subtraction. Can you guess where we're going next? We've added, we've subtracted. Now we're going to multiply. Okay, I'm going to give you new functions though. So example 4. I can get it on the screen. Given What do I want to give you? Let's see. F of t equals t plus 2, and g of t equals, how about t squared minus 3? And we're going to find f times g of t. Now be very careful. This times needs to be filled in. Next year when you go to Secondary Math 3, there'll be an open circle here, and it means something that's not times. It means f of g. So that's something different that we're not going to be doing this year. So make sure that dot is definitely filled in for times. Okay, so we need to go in the order they list it. First is f. So I'm going to write f down, t plus 2. Notice how I put it in parentheses because I want to times all of it by, so put times by g of t, which is t squared minus 3. Also, I put that in parentheses, so that's important. The only one we really didn't have to worry about parentheses was addition. Okay, we know how to times these. Think about it. What method do we use to times a binomial times a binomial? Distributive property, right? Okay, I'm looking for a different color. Here we go, different color. So we start with our t, and we multiply. T times t squared. That is t. When we multiply, we add exponents. Multiply, add. T to the first times t squared is t cubed. You're not done with the t, though. Make sure you finish your Santa hat off with t times negative 3, which becomes negative 3t. And I do put a little curl at the bottom of my t's so that it doesn't get confused for being an addition sign. Okay, now we need to multiply in a positive 2. Make sure you look at the sign. It is a positive 2 times t squared, which becomes positive 2t. And then we have positive 2 times, what type of 3 is that? It's a negative 3, so make sure you always look at the signs. 2 times negative 3 is negative 6. Okay, so first we used distributive property, so I'll just put distribute. Can you guess what's next? Combine like terms. Okay, so in this case, I have linear terms here in the middle that are like terms. So I have t cubed, negative 3 trees plus 2 trees, just whatever starts with a t. Negative 3t plus 2t is negative 1t minus 6. And that would be our f times g evaluated at t. So that one we didn't have to plug in. If I asked a secondary question, which said, what is f times g evaluated at 2, then we would need to go further. So this one's done as is, but if it says evaluate at 2, we need to plug in a 2. Remember, whenever we plug in or evaluate, you need to use parentheses. So each one of these t positions, I put parentheses. So 2 in parentheses cubed minus 2 in parentheses minus 6. Replacing all of the t's. Again, follow, simplify with PEMDAS. So nothing inside the parentheses to do, but we do this time have exponents. So what is 2 cubed? It means 2 times 2, which is 4, times 2, which is 8. So 8 minus 2 minus 6. I actually, let's see, we could say there's multiplication with the negative 1 here, but let's just treat it as subtraction. So subtraction needs to go left to right. 8 minus 2 is 6, minus 6 is 0. So f times g evaluated at 2, so it's not times 2, it's of 2, evaluated at 2 equals 0. Okay? So if there's a number here instead of a variable, we have an extra step. All right, there was our multiplication. One more. See, it's not too bad, is it? Now we're going to do division. Last problem. Example 5. Evaluate, but I'm going to give you different functions this time. What do I want to give you? Okay. Given f of t equals 5t and g of t equals 25t plus 10. And we're asked to find g divided by f evaluated at 3. Okay, again, order is important. Look at who is on the numerator. The numerator is g, so we need to make sure g is in the numerator. 25t plus 10 divided by, the denominator is f. The denominator is f, 5t. If you just stop right there, you are not done. With division, you want to see if anything cancels. Now be careful. If neighbors are being added or subtracted, you cannot just cancel. That's illegal to just cancel. You can only cancel if neighbors are being multiplied. Only cancel if, or even simplify. I'm going to put simplify / cancel if neighbors are multiplied. So right here, the 5 and the t, those are being multiplied, so we can look to cancel a 5 or a t. But upstairs in the numerator, we can't, right now, the way it's written, we cannot cancel because there's a plus sign. But with some manipulation, I can get something to cancel. Look at 25t plus 10. We've practiced this a lot this year. What we want to look for is a greatest common factor and factor it out. What is the largest number that divides into 25 and 10? That would be 5, right? Do they both have t's to give away? Nope. So the greatest common factor is 5. And we pull it out. It doesn't just disappear. We pull it out and then write what's remaining. So when you're factoring out, you end up dividing each term. 25t divided by 5 is 5t. A positive 10 divided by 5 is a positive 2. Remember how distributive property and factoring are inverses. If I went back through and multiplied these back together, 5 times 5t, I get 25. And 5 times 2, I get a positive 10. So they just undo each other. But outside here, this 5 is now being times to the parentheses, which is why when we look at our denominators, they are allowed to cancel because now their neighbors are being times. So the 5's cancel. And we're left with 5t plus 2 over 5t. But technically that is just g divided by f evaluated at t. We were asked to evaluate at 3. So our next step is to replace all t's with the number 3 and make sure it's simplified. So where these two t's are, we need to put parentheses. So 5 parenthesis 3 plus 2, 5 parenthesis 3. Okay, let's simplify. We're going to need to simplify the numerator first. I have multiplication and addition, so please excuse my dear Aunt Sally. Multiplication comes first. 15 plus 2 over 15. Finish adding. I have 17 over 15. Does that simplify at all? No. does not simplify. So you can also write this as 1 2/15. But since it started as fraction form, you should leave it in fraction form. You should not write it as a decimal. That's kind of a general rule. Unless requested otherwise, if it starts in a certain form and doesn't work out nicely, leave it in that form. So we're going to leave it as fraction form. Okay, so for the remainder of class, you are to work on the gray worksheet. It looks like this. Evaluate and combining functions assignment. So the first page is super easy because it's just evaluate only. And then the rest of it is combining functions. See how you're given two different functions and you're just supposed to do subtraction or addition, whatever operation it is, but notice the number. You have to remember to plug that number in, and this one is h plus g, which is the same way as writing f plus g like that. But they both mean add them, and then this one is evaluate at -3 and this one's evaluate at 7. Okay?